You know, when you drive past a car crash, you see the flashing lights, the twisted metal. It all looks like pure chaos. But what if I told you that inside that chaos, there's a highly precise, life-saving performance going on? Today, we're going to pull back the curtain on the hidden choreography of modern vehicle rescue, a strategy that has completely changed to save more lives. Let's dive in. Okay, so let me ask you this. For decades, the answer to this question seemed totally obvious. You have to keep the patient perfectly still to protect their spine, right? But what if that core belief, the one everything was built on, was actually wrong? This one question has revolutionized how first responders approach a trapped patient. And trust me, the answer is not what you'd expect. And here it is. The entire game has changed. We've moved from this obsessive focus on minimizing every tiny movement to a new evidence-based focus on minimizing time. So why the big switch? Well, it turns out that time-critical injuries, things like massive internal bleeding, are way more common than unstable spinal injuries. The real enemy here isn't movement, it's the clock. And look, this isn't just some new idea someone came up with. It's baked into official protocol now. This quote really gets to the heart of it. The goal is to get that person out of the car as fast as humanly possible, but, and this is the key part, to do it with care and precision. They call it gentle patient handling. It's all about being fast and smooth, not fast and reckless. Okay, so to really understand this choreography, we have to learn the language. On a crash scene, rescuers use a kind of shorthand that lets them communicate an entire complex strategy in just a couple of words. Let's break down the basics. So the very first thing they have to figure out is why the patient is trapped. Is it physical entrapment, where, a dashboard is literally pinning their legs? Or is it medical entrapment, where their injuries are so bad they can't move, even if the door is wide open? This one distinction determines everything. Are we cutting the car apart, or are we focusing on treating the patient first? And that leads directly to the two main game plans. If that patient is critically injured, we're talking life-threatening, the team goes into rapid extrication mode. Here, speed is the one and only priority. But if the patient is stable, they can use what's called a controlled extrication. It's still fast, but it allows for a more methodical, careful plan to get them out. Which brings us back to that really important phrase, gentle patient handling. This is the guiding principle behind every single move they make. So instead of strapping a patient down so they can't move a millimeter, the focus is on smooth, coordinated, and deliberate movements. Think fluid and efficient, not rigid and slow. All right, we've got the language down. Now let's look at how they set this stage. Before anyone touches the car, first responders have to turn that chaotic scene into a safe and totally organized workspace. The very first thing the commander on scene does is a 360-degree reconnaissance. It's basically a quick walk around of the whole scene to gather critical intel. They're counting cars, looking for hazards like downed power lines or fuel spills, and trying to get a count of how many patients there are. This one lap shapes the entire initial game plan. And this is how they create order out of that chaos. It's actually brilliant. They set up 3 zones, like ripples in a pond. The hot zone is right around the vehicle. Only the essential rescue crew is allowed in there, and they're in full gear. The warm zone is a step back. That's where they stage tools and have backup personnel ready to go. And the cold zone is the outer ring for command, police, and traffic control. It's all about safety and efficiency. Okay, now we get to the core of the choreography itself. Every single vehicle rescue follows a clear 5-act structure. Each phase builds on the last, making sure absolutely nothing gets missed. Yep, this is the story of every rescue, told in 5 chapters. It starts with approach and scene control, which we just talked about. Then you stabilize the vehicle, access the patient to figure out what's going on, create the space you need to get them out, and finally transfer them to medical care. It's a perfect roadmap from chaos to care. But the absolute pivot point, the one moment where the entire rescue can go one of 2 very different ways, is phase 3. This is when a medic gets to the patient and does an assessment. Notice, it's not about the big cutting tools yet. It's all about the patient. Their medical condition is what dictates how fast the team moves and exactly what they're going to do. So how do they make that huge life-or-death call in a matter of seconds? They use a simple but really powerful tool called the APEX algorithm. It's a quick 3-step check. First, A, for alertness. Is the patient unconscious? If they are, boom, decision made, rapid extrication. If they're awake, they move to P for pulse and airway. Do they have a pulse? Is their airway blocked? If there's a problem here, again, it's rapid extrication. It's only if they pass both of those checks that the team gets to E and evaluates if a more careful, controlled extrication is possible. It's incredible. This simple tool sets the pace for the entire rescue. So once that plan is locked in, they move to phase 4, making space. And I want to be clear, this isn't just random destruction. Each of these techniques is a precise solution to a specific problem. Removing a door gives you better access. A full side removal or a third door creates a massive exit pathway. And if a patient's legs are trapped under the dashboard, a dash lift or roll can create those few critical inches of space needed to free them. Every single cut has a purpose. But this carefully choreographed rescue is facing some major new challenges. The very cars that are designed to protect us in a crash are, ironically, making the job of rescuing us more complex and, well, more dangerous than ever before. Here's a perfect example. Ultra-high-strength steel. To make cars safer, they're built with these super hard metal alloys in the frame. The problem? The traditional jaws of life literally can't cut through it. It has sparked a constant arms race between car designers and the people who make rescue tools. And then you have the hidden dangers, like an airbag that didn't deploy in the crash. That thing is essentially a controlled explosive waiting to go off. So rescuers have to live by the 5-10-20 rule. Stay 5 inches from a side airbag, 10 from the steering wheel, and the full 20 inches from the passenger side airbag. 20 inches! Getting that wrong, putting a tool or even your head in that zone, it can be absolutely catastrophic. And of course, the newest challenge comes from electric and hybrid cars. They bring dangers you can't see or even hear. There's the risk of high-voltage electrocution from those bright orange cables, and then there's something called thermal runaway. It's a type of battery fire that is incredibly hard to put out, and it can reignite hours, sometimes even days later. So, to make an EV safe, crews have a special procedure called the double disconnect. First, they have to find a specific wire called the first responder loop and cut it. That isolates the massive high-voltage battery. Then, second, just like a regular car, they disconnect the normal 12-volt battery to shut down systems like the airbags. It's a critical two-step process to disarm the car before they can work. And with EVs, there are new, absolute, non-negotiable rules. Rescuers are trained to spot these no-cut zones. You never, ever cut or puncture the main battery pack, which is usually right in the floor of the car. And you never cut those orange high-voltage cables. A wrong cut here doesn't just break a tool. It could cause electrocution or trigger one of those unstoppable battery fires. So you see how we went from a simple question of speed versus stillness to this incredibly complex choreography of medicine, mechanics, and cutting-edge technology. And it really leaves us with a final question to think about. As our cars just keep getting safer, stronger, and smarter, more like computers on wheels, how will the amazing men and women who rescue us from them have to adapt next?